In this tutorial, I'm going to show you how to lay out your loads inside of Revit. At this time, you should not be making any geometry changes to the model, and you have verified that no discontinuities exist within the model. Let me also remind you that you should be using the Revit template that is set up to export your model. In order to view the loads, ensure Structural Loads is checked under the Analytical Model Categories tab within the Visibility graphics. Right now, we're just going to focus on area loads. To lay out your area loads, you must select the Analyze tab at the top of your screen and select Loads, Area Load. Choose the load case from the drop-down menu. Type in the surface load in pounds per square foot. You can draw the area load using the following drawing tools. In this example, I'm going to use the Pick Line tool. And then trim the line to ensure that everything is connected. Select the surface load, and inside the Identity Data section within the Properties browser, next to Description, add F1 to define the floor name. Next to Comments, add the deck type using the following table. These are the metal deck types from the Volcraft catalog. In this example, we're going to be using 20 gauge 6.5 composite deck using normal weight concrete. Add the deck orientation to define the span direction of your deck. The deck orientation rotates counterclockwise, where 0 is parallel to the x-axis and 90 degrees is parallel to the y-axis. Note that the deck orientation should not exceed 180 degrees. In this example, the deck orientation is 0 degrees because the deck is spanning left to right. Under level name, ensure that the level that you are assigning the surface load on is the level in this parameter. If you would like to add another load in the same place, select the surface load, hit Ctrl-C on your keyboard, and align the load in the same place. And change the load case type, as well as the force value. Notice that we will not change the floor name in this case because the geometry is identical. Let's quickly verify that both loads are in plan. Hide the live load so that we can view the dead load. Let me show you what you need to do in order to have multiple loads on a level. Let's refer to the documentation to make this more clear. You can see on level 2 that we have 3 different floor names. You will have to update the floor name and level name that the load is associated with at each level. Notice that F1 at level 2 contains both superimposed dead and live load. F2 at level 2 contains different superimposed dead and live load as F1. Note that you can copy the surface loads from level 2 and paste a line to current view to level 3 if the loads and geometry are the same. You will need to update the floor name for each surface load. For the floor name F1, this is the live load that is associated to it with the following properties. For the floor name F2, this is the live load associated to it with the following deck properties. For the floor name F3, this is the surface load with the following deck properties. Let's view the loads on level 3. This is the surface load applied to the floor name F4 with the following deck properties. This is the surface load applied to floor name F5 with the following deck properties, and so on. You can view these loads in a 3D view in your model. Let's quickly go over how to assign line loads to your model. Go back to the Analyze tab, select Loads, Line Load, and change the load case appropriately. I'm going to assign a 0.5 kip foot line load to a beam. You must type in the correct level name before you assign the load to a beam on level 2. You must make sure that the level name and the identity data matches the level name under the placement plane. Select Line Load and click on the Pick Lines tool. Select the beam that you'd like to assign the load to. When assigning line loads in Revit, you must make sure that the line load is the exact same distance as the beam that the load is being applied to. The load also cannot vary over the beam length. If the load varies over the beam length, you need to update this in Etabs. Let's assign a line load to the roof. You can also view these loads in a 3D view. It is important to note that you can also add force in the X and Y direction as well as moments in the X, Y, and Z direction. Finally, let me show you how to add a point load to your model. Select Point Load, the appropriate load case, and add the point load to your model. You must also make sure that the level name matches the placement plane. You can assign a point load anywhere in your model. Once again, you can view these loads in the 3D view. Before we open up Dynamo, let's take a quick look at the Revit Model Data Excel spreadsheet to make sure that there are no loads in it. After you have verified that there are no loads in the spreadsheet, let's go back into the Revit model and open up Dynamo. Open the Export Loads to Excel script. Click on Run on the bottom left-hand side of your screen. Let's take a look at the Excel spreadsheet. Let's verify the unique name for these two line loads. Click on a beam with a line load associated to it to ensure that the beam unique names are the same. The beam unique name is 181. Similarly, for the line load. This beam has a unique name of 111. This is correct. In my next tutorial, I'm going to show you how to import the Etabs run file.